G'day everyone. Today we are talking about section 1.3, solve linear equations. I can solve a linear equation involving all four operations, adding, subtracting, multiplying, and dividing, including having a variable on both sides. And then of course I can solve word problems by writing an equation and solving the equation. So before we can talk about solving equations, we have to ask the question, what is an equation? What makes a problem an equation versus an expression? So in section 1.2, we looked at expressions and simplifying expressions. Here we're talking about equations. The difference, the equal sign. If the problem itself has an equal sign in it, it's an equation. If it doesn't, like you'll notice all the problems in 1.2, none of them were given with equation signs in them because they're expressions. And then we talk about linear equations. That's what we are focusing on in this section, is linear equations. A linear equation, there's two components that we look at. At first, we say the largest exponent is 1. So there are no squareds, no cubes, no fourth powers, no fifth powers in the problem. Another way we can say this is that it can be rewritten in the form y equals mx plus b. And some of you recognize that, and then we will talk about that a lot in chapter 2. Solution is just a fancy way of saying answer. In middle school, you talked about the properties of equality that said if I add the same number to each side, or if I subtract the same number to each side, or multiply the same number to each side, or divide the same number to each side, then the equations remain equal. That's what allows us to solve equations. All right, so solving equations, what we need to do is isolate the variable. That's when it says solve for the variable, we need to get the variable equals. So in this case, we're trying to get y equals. How do we get y by itself? Well, we have to undo this minus 7. So what is the opposite of subtracting 7? It's adding 7. Yes, you need to show this work. So I'm going to add the 7, so those cancel, and I'm left with y. 4 plus 7 equals 11. Now, in middle school, they may have talked about drawing the fence or the river. If you need to draw the fence or the river and doing that, because what happens on one side of the river happens on the other, or like I was taught saying that's a mirror. What happens on one side of the mirror happens on the other side of the mirror. Whatever works for you. If it helps you to draw that vertical line, the river, the mirror, the fence, whatever, go for it. If it doesn't help you, then you don't have to. But that is something that you can do. Now, check. This is something you probably haven't had to do much of. You need to show your answer works. All right, so when we go to check, you can do it below, you can do it beside. Typically what I will do is I will draw a dashed line to show this is a separate part of the problem. And you're going to take your answer, plug it back in. So is 11 minus 7 equal to 4? It sure is. It checks. When you are doing checking, you need to show it down to a single operation. If you wanted to go further and go, okay, 11 minus 7 is 4, and go 4 equals 4, and then draw your check mark, that is perfectly acceptable as well. Some teachers may, when you have to show checking for them, may actually ask you to go all the way down to where you get the same number on both sides. All right, here we have 5 times d. The opposite of multiplying by 5 would be to divide both sides by 5. 30 divided by 5 is 6. So we get D equals 6. And again, show our checking. Is 5 times 6 equal to 30? Yes. And again, if you wanted to go all the way, you'd say 30 equals 30. But that is showing the checking your solution part. All right, what do we do when there's multiple things going on here? Now, if we think about order of operations, when we are solving problems, we kind of do order of operations backwards. We look, can we undo adding and subtracting? And then we look, can we do undo multiplying and stuff like that? So in this case, when we have some adding and subtracting, we are going to want to do that first. So we are going to add the 10 to both sides. Again, those cancel, so we get 4n equals, and then we get 24. And again, to get rid of a coefficient out front, we divide, so then we're left with n equals 6. Again, we need to check. If the directions just say to solve, then you do not need to show checking. But like this one, the directions said check your solution, so you need to show it. Now, this is more than a single operation, so we need to do, oh, sorry, it was equal to 14 in the original problem. Again, when you're checking, you're going all the way back to the original problem. More than one operation, so we need to do some work. 4 times 6 is 24. Is 24 minus 10 equal to 14? Check, it works. And again, if you wanted to go all the way, you could go all the way and say 14 equals 14. Go ahead, pause the video, and try the last one. All right, so here the order was switched, so you had the number out front. So you have to still subtract the 8. Again, whenever there's a term without a variable, that's called a constant. You are always going to move the constant first. I shouldn't say always. Usually going to move the constant first, so that we can get the constants on one side. And so then we had negative 4x equals 12. We divided by negative 4 to get negative 3. Plug it back in and check it. All right. So now that we're all familiar and refreshed on solving equations, we're going to throw a wrench in here. What happens with fractions? How do you get rid of a fraction? Multiply by the reciprocal. All right, so in the first one here, we have 9 over 2, or 9 halves, h equals negative 1. So we are going to multiply both sides by 2 over 9. Again, why we do this? The 2's cancel, the 9's cancel, and we're left with just h. On the right side, again, you can always make an integer as a fraction over 1. We multiply the top, we get negative 1 times 2, which is negative 2, over 1 times 9. We have to ask ourselves, does negative 2 over 9 reduce? No. The directions said just solve for each variable. It does not say to check, so you do not need to show your checking. If you wanted to, you could plug it back in and check just to make sure you did it correct. That's always a smart choice. All right, go ahead and try the next one. And if you feel comfortable, try the last one and check back. All right, so the middle one, we just simply multiplied by the reciprocal of 2/3, which is 3 over 2. Again, the fractions will cancel each other out, that you get just g. 3 times 8, 24. 2 times 1 is 2. 24 over 2, or 24 divided by 2, reduces to be 12. That's how we got 12 on that one. On the last one, again, we had this plus 1 here we had to subtract. So we subtract that first. So then we had negative 3/4 g equals 7. Multiply by the reciprocal. Again, whatever the sign is of the original fraction is the same for the reciprocal. So we're multiplying by negative 4 over 3. Again, the 4's cancel, the 3's cancel, the negatives cancel. You're left with just g. The 7 is over 1. And then when I multiply, I get negative 28 over 3. Now, in this class, I do not want mixed numbers or decimals. All I want is reduced fractions. So in this case, negative 28 over 3 does not reduce. There's your answer. Okay. All right, another one of our targets was that we can solve word problems. So we're going to look at a couple word problems here. The first one being a t-shirt one. So it says FCCLA is ordering t-shirts from a catalog. Each shirt costs $15. The cost of shipping is $6 no matter how many shirts are ordered. That's called flat rate shipping. So whether you order 1 shirt, 10 shirts, 100 shirts, it's just $6 regardless. The total cost was $111. How many t-shirts did FCCLA order? Now, if you are having problems writing the equation right away because there's a lot of information, take a step back and think about what is going on here and write what's called a verbal model. So the cost equals how many ever shirts we order plus shipping. And then we can plug in information we know. We know the total cost was $111. And we know shipping was $6. Now it says each shirt costs 15. How can I represent the number of shirts? This is where you're going to pick a variable. If you want to be boring, you can just pick X. If you want to pick something else, pick whatever else you want. I'm going to be boring and use X. Now I have an equation. So sometimes when we're reading some of these word problems, if we can write a verbal model or a written model to problem solve, we can then use that to help make the equation. And then of course we're going to solve this equation. So we're going to subtract 6 and we get 105 equals 15x. Divide by the coefficient 15 and we get x equals 7. Now, you're going to hear this phrase a lot from me. A word problem has a word answer. In other words, you need to have a label. In this case, we're talking about shirts. So they ordered 7 shirts. Another word problem. I know we all just love word problems, but percentages always tend to be an issue for some people. So we are going to talk about a word problem involving percentages here. So again, our directions, write an equation and solve. So it says a salesperson at a car dealership has a base salary of $25,000 per year, as well as a 5% commission on all sales. How much total sales does the salesperson need in order to earn $50,000 in 1 year? All right, so their salary, so their total income or their total is their salary plus commission. And so there are a lot of sales jobs that are this type of setup where you have a base salary and then the more you sell, the more commission you make. Like an insurance agent, for example, has a commission built into their deal. So they have an incentive to sell more insurance because then they're going to make more money. All right. Our total, how much are we wanting to make? We're wanting to make 50,000. Our base salary is 25,000 plus our commission. What's our commission? It's 5% of sales. Now, when doing problems, we don't want to do a percentage as a percentage. We want to convert it to a decimal. So what is 5% as a decimal? Well, it is 0.05. And what is our 5% of? Of our sales. So you could use S for sales if you wanted. Now this brings up a good point. When you are working with different variables other than X, and even when working with X, you need to be careful. Make sure your X and your times don't look the same. So here, when I'm doing S, I make sure my S is half the size of my numbers. So my 0.05S, my S and my 5 don't look the same. So it's not 0.055, it's 0.05S. Now, so 5%, is 0.05 as a decimal. That's what we're using right there. All right, and the same thing, we're going to solve just like we have been. We're going to subtract the 25,000, and that's because it does not have the variable attached to it, because we're trying to get the variable by itself. So basically we're saying that they made 25,000 in commission, and then we're going to divide by the coefficient to get S by itself, and we find that S is 500,000 in sales. Again, a word problem has a word answer. And the last thing we're going to look at is what happens when there's a variable on both sides. Well, there's kind of this two-part thing, and one of it is we need to get the variables on one side, and then the constants on the other side. So you'll hear, like, I'll say variables to the left, constants to the right, or variables to the right, constants to the left. We have to get variables on one side and constants on the other so that we can solve the problem. My word to the wise, when you're looking at these problems, look at your variables and move the smaller one. So in this example, where it says solve 4a plus 5 equals 2a plus 15. Where is your smaller variable? Well, it's right there. Move that one because that way I'll get to work with positive numbers. So I am going to subtract 2a from both sides. We've now moved the variables to the left, which means constants go to the right, which means this constant on the left side has to move over. How I look at it when I'm doing these problems, I'm going to have one thing that completely cancels from both sides. After I've done my canceling, 4a minus 2a, 15 plus negative 5 would be 10, and now it's just a matter of solving, and I get a equals 5. Again, it just says solve, so I do not need to show checking. You obviously could plug it back in and show that it checks, but the directions do not ask us to do that. All right, go ahead and try the last two. Again, it is okay to get a fraction. Just leave it as a reduced improper fraction if it happens. All right, so the middle one was pretty straightforward. Subtract 2b to move the b's to the left, add 4 to move the constants to the right. You get 3b equals 12. Divide by the 3 and you get b equals 4. This one's a little trickier. The C problem, I added 4c because I like to avoid negatives. In the end, it doesn't really matter. But you get 6c equals negative 8. If you'd have subtracted 2c, and then subtracted 6, you would have 8 equals negative 6c. Either way, when you reduce it after dividing, you get c equals negative 4/3. All right, we got a couple perimeter problems and we'll be done. How do I find the perimeter of a triangle? I add up all the sides. So perimeter equals a plus b plus c. So I'm going to say the perimeter, which in this case was 26, is equal to, and I'm just going to start with the one on the left, 14 minus 2x plus 2x plus 1 plus 3x minus 1. In order to solve this, what's the first thing I need to do? I heard it. Collect like terms. So I'm going to go through and add my like terms. And now I have an equation that I can solve, so go ahead and solve this equation. And again, labels, if in this problem there was a label that's the perimeter is 26 inches, So I know that when I'm talking about values, they're going to be in inches. All right, one last problem. It says the perimeter of a rectangle below is 62 feet. Find its dimensions. Well, we have to remember, what is the formula for perimeter of a rectangle? And you may remember it's 2 width plus 2 length. And yes, I know I make my L's funny, but the lowercase l looks like a capital I, looks like a 1. So I tend to do this cursive italic L. Now, width and length, you can pick whichever one you want to be width and whichever one you want to be length. According to the post office, whichever one is going to be longer is considered length. So if I look, 2x plus 3 is going to be longer than 2x minus 4. But ultimately, like I said, it doesn't matter. So we're going to plug them in. So we get 62 for perimeter equals 2 times. And again, we're plugging in for a variable. So we are going to use parentheses. And now it's a matter of distributing, collecting like terms, and solving. So go ahead and do that and check back. All right, so we did the solving. We distributed in green here. You got 8x minus 2. You add the 2 to get 64 equals 8x divided by 8. You get x equals 8, which is all fine and dandy, but the problem doesn't say to solve for x. It says find its dimensions. So you have to plug 8 back in to get the length is 19 feet and the width is 12 feet. Make sure you read the directions carefully so that you, while solving correctly, don't give away points for full application. If you have any questions, make sure you ask in class. Otherwise, have a great day, everyone.